So this session we are going to look at how to do our linear regression using R. Okay. So the Jupyter notebook format is going to be same, right? So you have this once for markdown, and this is for your reading. So what we are initially going to do is we are going to use a function, okay, which is read.csv. So basically it reads a file which is in CSV format, and you need to give the path. So it takes one parameter. So here is the path. Don't worry about this path. So this you can find out when you load something in this Kaggle environment. And then what we are going to do is we are going to look at some of the top rows that I have. Okay. So basically if you look at this particular data set, how many columns it has got? It has got 5 columns: X, TV, radio, newspaper and cells. Now if you think of X, it is just a auto incrementing number, so probably not useful for our analysis purpose. And basically all these rows actually belong to one store, okay, one store, where you want to find out that what was the advertisement made in TV, what was the advertisement made in radio, and what was the advertisement expense made in newspaper, and what was the corresponding sales. So essentially the problem is that if someone tells you that for a particular sales how much if they have spent so much of amount of money in TV, radio and newspaper, what should be the corresponding sales amount. Okay, so that is what is your problem statement. That is what you want to do through regression. So you already know the theory of regression, so I'm not going through that. So first of all, already know that how you can find out some of the summary statistics of a particular data frame. So this what has happened is that you have stored this CSV data in a data frame, okay, and this is how the data looks like. And now what I'm going to do is I'm going to execute this summary command, which takes one parameter, which is the name of the data frame. So if I run this, it will tell me different parameters like what is the minimum value, what is the first quartile value, median, mean, third quartile, max, and so on and so forth. Okay, some of the summary statistics. Next, what I want is I want to remove the first column. Okay, so if I want to remove the first column, I can give something like this: ADVT equal to ADVT minus 1. So from the data frame now, the first column which just has the serial number will be removed. Okay, so let me run this, and now if you want to again going to look at this summary, you will see that now X is not there anymore. Okay, so you have already removed it. Now for any type of model, what we do is we bifurcate the data into a training set and a testing set. Okay, why do we do that? So basically so like any student, the model also has a tendency to overfit, rather than trying to actually learn. It can memorize and give you the results. Okay, so to avoid that, what you do is that when you try to or make the model find the parameters based on the data, you don't give him the entire data, right? So you give him some part of the data which is called as the training set, and rest of the data is called as testing set. Okay, so the linear regression model that we are going to build on the training set, and we are going to do the testing on testing set. Is that clear? So what I am going to do now, before I proceed further, let me do one thing quickly. Let me look at the dimension of this particular data set. Okay, so for that, what I'm going to do is I'm going to use a command called as dim advt. Okay, and if I just run this line, it will tell me how many rows and columns it has got. So it has got 200 rows and 4 columns. Now typically when you are doing splitting in a training set and testing set, you pick a random sample. Okay, and maybe you will pick 70 to 80% for the training. So 140 to 160 rows out of these 200 rows you will pick as the training set, and rest you will use for the training set. Okay, is that clear? So now how I can create this thing? So basically I am going to, so all these rows has an index. The index starts from 1 and goes up to 200. Okay, So what I'm going to do is I'm going to create random numbers between 1 to 200. How many random numbers? That many rows I want in my training set. So if I want 160 rows, I will create 160 random numbers. How can I do that? So I am creating kind of a list which I am taking a sample from 1 to number of rows in ADVT. So this number of rows actually returns this value 200. And how many I want? I want 0.8 into n rows. So I want 160 numbers. So if I run this, okay, and if I just run this statement, you will realize what is happening. So you'll see that randomly it has created 160 numbers, okay, and this is sampling without replacement, so there will be no repetition in the value. Okay, if you want to do repetition, there are parameters in sample, but that is not required for us. Now what I want is I want to create two kind of data frames or two tables, one for training set and another for testing set. So if you remember, when I go to a data frame, it is some kind of a comma structure where in the first part, and the comma has a preceding part and a succeeding part. Now the preceding part is for the rows and the succeeding part is for the columns. Is it clear? Okay, so what I'm going to do is I am just going to mention that I am going to take these rows. Okay, so this is the row number that I've already generated. So these rows I am going to take, and I'm giving a like comma, and I'm not mentioning anything. So when I don't mention anything, that means I am here mentioning 1 to 4. Like I want to take all the column. So as I am not picking any particular column, so I just can give comma, and I can understand that it will take all the values. And interestingly, for creating the test ADVT, what I can do is I can do a minus train index. So this is very useful. So what does that means is that don't take whatever is in train index but the other ones. Okay, so this way, if I create it, okay, now let's do one thing. Let's just check the dimension of train ADVT. So can you tell me what it will be? So it will have the 4 columns, there is no doubt about it. Okay, and it will have 160 rows in it, right? And similarly, if you check the test ADVT, okay, it will be 40 cross 4, right? So these are non-overlapping sets. Okay, now fitting linear regression is extremely simple. Look at this particular line. So look at the right part first. So the formula or the model that will be invoked is by the keyword LM. LM means linear model. Okay, and this part is called as a formula. Okay, it has two parts. If you see that there is a comma over here, the left part is the formula where you mention that what is the independent variable, what is the dependent variable, and the right part is that on which data frame it will get those variables. So these are the two parts that are necessary. And what is this LM ADVT? So this is just that I am storing this model in another variable, that's all, nothing more, nothing less. Okay, so if I do this, okay, what I am doing over here is look at this part, right? That cells, so this is what I want to determine, right? So this is my dependent variable, and after that I will give a tilde, and then if you see there is a dot sign. Dot sign means that you are actually using all the other parameters that are available as independent variables. So if you want to specify 1 or 2 like that, so what you could have done is you could have written like TV plus, TV plus whatever was the name. So let me quickly check the name. Yeah, TV plus radio. So you could have done like that. Okay, so as I am going to use all of TV, radio and newspaper, I don't need to mention this. I can just remove all this and can give a dot. Is it clear? Okay, so I will simply run this now. And you remember that when we have learned linear regression, so it is not only fitting the model which is important, but we need to inspect the model, right? That how good my model has fit. Okay, so for that the command is you apply a summary on this model. So if you apply a summary, it will tell you that the things that we are interested when even we were looking at SPSS. So see, it is telling you the values of intercept, TV, radio and newspaper. So what are these? These are the coefficients, right? These are the coefficient values, right? You know what is the standard error? Standard error is the estimate if you create different random samples and create and find out this value of intercept, TV, radio and newspaper coefficient. Standard error is nothing but their standard deviation. Okay, and you already know that for linear regression you apply a t-test. Okay, and it is giving you different values of t and the probability of that. So this is your p values, if you realize, and wherever it is giving you this star 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 sign, that means that this is a significant attribute, right? So for this attribute, the null hypothesis is not true. So these attributes are important. So if you look at intercept, TV and radio, for all of them, the p values are very small, but for the last one, newspaper, it has a high value. So for this one, you cannot reject the null hypothesis, and you are actually telling that newspaper is not an important attribute as far as advertisement spent is concerned. Okay, so far so good, and of course we can find out some other things like adjusted R square. So adjusted R square is 0.89, multiple R square is 0.90. So basically it tells you that it explains around 90% of the variability. This model explains 90% of the variability that is there in the model. That is the first thing. And second thing is the difference between multiple R squared and adjusted R squared is, it turns out that if you increase the number of variables, okay, so you start with TV, then you go to TV and radio, then you go to TV, radio and newspaper, and you calculate the R square, actually the R square goes up. So monotonically it increases as you increase the number of variables. So for that, what you do is you take the R square and you adjust by number of variables you have considered as independent variables. Okay, so you adjust by that. All right, and this is so t-test is about testing individual variables statistical significance. And you know what f-test does? F-test actually test the entire model significance. Okay, whether the model is significant or not. Individually, even if we say all the models are significant, it may not mean mean a lot, but you need to still do a f-test and see if the model is significant. Okay, and you get a f value, you get the corresponding p values, so you know that this is a significant model. Finally, what we are going to do is we are going to predict, based on the testing set, okay, what is my predicted value of sales. So what we are going to do is we are going to use, so this takes two parameters. First is the model, okay, which model you are going to do for prediction, and in what data you are going to do prediction. So the model name we have specified here, and we have also specified that on what data set we are going to do this prediction. Okay, and then what we are going to do is we are going to store, so this is actually your actual value, and this y pred is your predicted value. And what you want your actual value to be as close as predicted value. Okay, so let me run this. Okay, and what cbind does is cbind says that it creates a data frame, and how it creates, it binds columns. Okay, so if you have one variable in test ADVT and another variable as y pred, okay, so if they have same length, you can add them in a data frame. So it will be better when I see this. So if I look at result now, okay, so you see that it has got a 40 into 2 dimension size, so 40 rows and 2 columns. Okay, and you can look at the predictions, right? So this was what was the actual value. So 12.9, you predicted it to be 13.55, this was 15.9, and so on and so forth. Okay, and can you tell me why these numbers are not continuous? This is because it is coming from the row index from the original variable, right? So it is created by this random sample, you see. Okay, now what we are going to do is we are going to do a basic scatter plot and see that how the actual and predicted is doing. Okay, so if I do like this, okay, so here is a scatter plot, and the scatter plot doesn't look bad because when the sales increases, the predicted value also increases. So that means our prediction is not that bad. Okay, and both, you know, it has the same scale, so it starts from 0 to 25. And you could have done also another thing. Let me do that quickly. So you could have calculated the correlation. Okay, so if they are good, okay, if you have predicted well, they should be well correlated. So let's see how is the correlation. Let me just run this. Yeah, so correlation you can see is 0.935, right? So it is high correlation. That means your prediction is doing well, right? And here the library that we have used for scatterplot is ggplot2. So this is one of the very important libraries for our visualization. Okay, but you know, we will do it like keep more elaborate discussion for later. And one of the things that happens in ggplot is that it builds the, you know, plot in layers. Okay, so what it is first telling is that it is on which data set. Okay, then it is telling, so this AES is actually for aesthetics, so it tells that which is the X column and which is the Y axis column. And then, you know, you add something like this with a plus. Okay, that whatever is there, you add them as points. So if you want to do a line, if you want to do a box plot, so there are separate options for that. Okay, so ggplot actually builds it, you know, layer by layer. So you have already seen. Okay, so as I have put it in the next slide, you know, it has got confused. So let me run this. Yeah. So now if you want a nice regression line, which you know, which you want to add, so see what we have done. We have again added another layer. Okay, added another layer where we have said that, you know, we are adding a you know, smooth line based on linear regression. Okay, so if I do that, what will happen is you will get something like this, right? So it tells us that this is the regression, you know, regression line, and these dashed lines that you see are the confidence intervals. Okay, so I hope, you know, you got some idea that how you can use linear regression, you know, to feed the data and you know, inspect the model, split it into, like, first split into train and test, and then feed the model, inspect the model, and then also you know, visualize your actual versus prediction.